over time. Okay.
Shape of a graph. So the first derivative test will give us a way of determining relative extrema. So we have a continuous function f over an interval I containing a critical point C. If f is differentiable over I, except possibly at C itself, then f of C is going to satisfy one of these descriptions. If f prime changes from positive to negative at C, so it's positive to the left, negative to the right, f of C is a relative max. If it changes from negative to positive, so it's negative to the left, positive to the right, f of C is a relative min. And if f prime stays the same, the sign stays the same, right, so it's positive both sides or negative both sides, neither is local maximum. This is the first derivative test. And this is how we're going to be determining relative extrema. And then visually what the first derivative test says. So consider a function using the first derivative test. You first want to find all the critical points, right? That means you have to take the derivative, determine where it is undefined, determine where it equals 0. Of all those values, determine which ones are interior, because those are your critical points. Then we do sign analysis. We analyze f prime, right? So what we typically do is create what's known as a sign chart, where we have intervals and the sign of f prime. Remember, positive f prime would mean it is increasing over that interval. Negative f prime would mean it's decreasing over that interval. Then just use the first derivative test. Does it go from plus to minus? If it does, that critical point is a min. Sorry, plus minus is a max. If it goes minus to plus, it's a min. Concavity was next. If f prime is increasing over an interval, f is said to be concave up over that interval. If f prime is decreasing over an interval, then we say that f is concave down over that interval. I'm not a huge fan of that terminology. I like convex and concave better. And so concave up is convex, concave down is just concave. No, but if f prime is increasing, isn't that just the same test as we looked at last time? F is increasing if its derivative is positive. What's the derivative of f prime? Positive f double prime means it's convex. Negative f double prime means it is concave. Thank you. Points at which the concavity changes is called an inflection point, or a point of inflection. Right? You probably briefly, I mean very briefly, discussed concavity in pre-calc. But you never were really asked for intervals. Right? Even if you're given a graph, it's really difficult usually to find a point of inflection just from a graph. So at what point does it switch concavity? Usually it's about halfway. Right, so if I look here, it's usually about halfway between. So you can see right here's the inflection point, which is about halfway of the, I guess, the dip in the hump. But that's not a real exact definition, and good luck trying to read that. But now we can, because we're in calculus. Which gives us a second test for extrema, called the second derivative test. I will be using the second derivative test with optimization next time, not so much with this section. F prime of c equals 0. F double prime is continuous over an interval containing c. If f double prime is positive, then it's a local minimum. Right? F of c would be a relative min. If f double prime of c is is negative, f of c is a relative maximum. So with the second derivative, it's the opposite. Positive results in minimum. Negative results in maximum. If f double prime of c is 0, inconclusive. visualization of the second derivative test. Given a function, what do we want? Everything. Intervals where it's increasing or decreasing, the monotonicity. All relative extrema. Intervals of concavity. Right, so where is it convex? Where is it concave? And all inflection points. Fun. Start with monotonicity. This is the analysis of f prime. What is that derivative?
3x squared minus 6x.
Is that undefined anywhere? What are the solutions?
2 and 0.
Are they interior? Right, so again, it's going to require you to know the domain. So those are both critical points. Now we set up our sign chart. So I have to first pick intervals. Here is how the intervals will be chosen. Start with the domain of f. You break up that domain at the critical points. There's the first interval. There's the second. There's the third.
The second interval wouldn't be closed bracket?
No.
Okay.
Because you don't want to include where the derivative is 0.
Right.
Pick any point in each interval. Plug it back into f prime to determine its sign. Not the value. We don't care about the value. All we care about is the sign. Bummer. 0 isn't an option. Let's pick a really large one. Negative 100. I like to plug it back into the factored.
It's going to be positive.
So we go, that will be negative, right?
Mm-hmm.
That will be negative. Negative times negative. Pick a value between 0 and 2. 1. Positive. No. Looks like it's working. Negative, right? What's positive times negative?
Negative.
Pick a value. 100.
Positive.
That's positive, right? 100 minus 2 is positive. Positive times positive. There's your sign chart. Intervals where f prime is positive means what about f? So where are we increasing?
From negative infinity to 0, then down to 2 to infinity.
Negative means f is doing what?
Decreasing
So which interval are we decreasing?
0 to 2.
Now for the extrema. Go back to the sign chart. Do we switch signs? What does it go from?
That's a positive negative.
What kind of extrema is that?
That's the max.
That is a max, right? There's a max at 0. Work with me now. Plug 0 back into f. What do you get?
2.
So that point is a maximum. Does it switch sign? What does it go from?
Negative to positive.
Which tells you it's what?
The negative one.
Where did it switch? At the critical point 2. Now just plug 2 back into f. 8 minus 12,
0.
negative 4, negative 4 plus 2, negative 2. Should be negative 2, right? Does it change sign again? We're done. That's the full analysis of f prime. That was only half of it. Now we're testing concavity. So this is an analysis of f double prime. What's f double prime?
6x minus 6.
Is there anywhere that is undefined?
No.
Because essentially what we're doing now is we're testing where f prime is increasing, decreasing, right? So we have to find critical points of f prime, Same definition. Not undefined anywhere, set it equal to 0. What are the solutions?
6. Oh, wait. 1. Sorry,
Just 1.
my bad.
Is that interior?
Yes.
So that is a critical point of f prime. I'm going to call it x star though. So I'm not really interested in critical points of f prime. I'm interested in points of f. So this is a possible inflection point. I don't know if it is yet. Now we do another sign chart. But this time on f double prime. We're going to set it up the exact same way. Start with the domain of f. Break it up at every critical value of f prime. So every x star. There's the first interval. There's the second. Ooh, we have a nice value in the first one. Take 0, plug it into f double prime. What do you get?
A negative.
I don't know, 10. Plug 10 back into f double prime. What do you get? Where would f be convex?
Once infinity,
Why?
because it's increasing
What's increasing?
concavity.
Concavity doesn't increase or decrease, it's a property. Something's increasing, but what?
Values?
The function.
So this was sine of f double prime, right? What is f double prime the rate of change of?
F prime.
So what's increasing?
F prime is increasing.
Which is the definition of concave up, which is convex. You also could have just said it was positive. And that would have been valid as well. So for this one, I will put an arrow here, but I'm not going to do it anywhere. Convex means up, concave means down. Where would be concave?
Negative infinity to 1.
Why?
Because it's decreasing.
What's decreasing?
F prime.
Because f double prime is negative, which means f prime is decreasing, which is the definition of concave. Look at the sign chart. Is there a sign change?
Yes.
Where?
At 1.
What is a point of inflection? now I have to go all the way back up and plug it into f. What's f of 1? Oh, that was easy.
Zero.
0. So there's an inflection point at 1, 0. I am too damn lazy to rewrite everything. So there's the increase and decreasing along with extrema. So that's the first derivative analysis. And there's your concavity with the inflection point. That is your second derivative analysis. Back in my day, this wasn't all we had to do. Because we then had to sketch the graph. So this was a 4-step process. First was the analysis of f. Domain, range, asymptotes, intercepts. Second was the analysis of f prime. Third was the analysis of f double prime. Fourth was then take all of that information and sketch your graph. And it gave you a really, really good sketch. Yeah, we don't do curve sketching anymore. You're welcome. Depending on the function, that could be like a 15-minute process.
I have a quick question. So does concavity mean anything for f of x, the first function?
Concavity is on f of x.
Okay. Because I know it's describing f prime.
Increasing, decreasing of f prime.
Yeah.
Concavity is for f.
Okay. I'm gonna have to read that first. It's not clicking yet.
It's just the shape.
Okay.
Is it opening downwards? That's concave down. But that's the graph of f.
Mm-hmm.
Does it open upwards? That's concave up. So that's what it's giving you. Of f.
Yeah.
It does have other meanings, like in economics, for instance, it has a meaning. Inflection points, I forget exactly what they're called, or exactly what they represent. I think it has something to do with like the elasticity or the break even, something along those lines. So it does have other meanings. I haven't encountered it in physics. I'm not saying it doesn't exist, but I haven't encountered it. But it does have other meanings, which is why we're focusing on finding them. And it's going to be the exact same thing, I think, for every problem, just different functions. Just somewhere. Yeah. I should probably just change it now before I get too involved with this problem. What's that prime? What are you gonna have to use that from?
Quotient.
Question.
I think paper for that.
Oh. I guess this means if you didn't do well on the derivatives test, you're not gonna have fun on this unit either, huh? Right? Low d high minus high d low. And over low squared. Looks like we're gonna have what? 1 minus x squared all over x squared plus 1 squared. Is there anywhere that is undefined?
No.
Nope. Not in the rear plane. One minus x squared is 0, so what is x?
Is it just one?
Not just 1.
Plus or minus one.
Are they interior?
Yes.
I'm not even gonna write out the critical points. Just gonna leave it. And go right to the sign chart. What's the domain of f?
All around number.
Everything. Negative 10. If you plug negative 10 in up here, what are you going to get? Saving too long.
Positive.
Negative 10 squared, is that going to be, that's positive. Is that larger than 1? What's 1 minus something larger than 1?
Negative.
Negative. Oh, that whole thing's being squared, so that's always going to be positive regardless. Negative divided by positive is negative. 0. That one's easy. Positive over positive. Oh, by the way, that function's even. Which means 10 and negative 10 give you the same result. Where is it increasing? Where is it decreasing?
Negative
-1, 1 positive.
Look for sign changes. Is there a sign change?
Yes,
Where?
at -1 and at 1.
All right, so start with the first one.
At negative.
That would be,
What does it do?
that would be me,
Because it switches from what?
from negative to positive.
What's G of -1?
Half,
What is it?
negative half.
What's the second sign change from what to what?
From +1 to, from positive to negative, so it's not
So where does that occur?
at 1.
And yep, that is max. Be careful, it's not technically a max, it's a relative max. What's G of 1?
1 half.
Now for concavity. Oh boy. Why am I using F? Should be using G. But that's such a pretty F. I want to erase it. What's F double prime?
Oh, that is gross. Actually, isn't that great? It's doable.
That? Now simplify.
Even to be calculated with 2x.
Factor out x squared plus 1 and then distribute. Looks like we get what? 2x cubed
Plus 6.
minus 6x?
That's plus.
Why is it plus?
No, you're right. We were trying to do this.
Yes! Is there anywhere that is undefined? What are the solutions?
Plus or minus root 3
And what else?
and 0.
Which are interior?
Everything. Yeah, this is a little gross.
So we're gonna have to go negative infinity to negative root 3. Negative root 3 to 0. 0 to positive root 3. And then positive root 3 to infinity.
You need one at least.
Let's just go in order. Negative 1,000. That's guaranteed to be in there. Plug it back into F double prime. What I'm probably going to do is do this. Negative times positive is negative. Positive. So it's negative over positive.
Will be negative.
Negative 1. By the way, I can actually simplify this even further. If you look at this term down here, it's not always going to be positive. Because you get x squared plus something, you get a positive plus 1. That's always positive. Good. Sign is determined totally by the numerator. Negative
Will be negative.
times negative.
So positive. Negative. Positive.
That was positive. Positive 1. Positive
Negative.
times negative is what?
Negative.
1,000.
It's the same.
Positive times positive. Where are we convex?
From negative square root 3 to 0 from 0 to square root 3.
Where are we concave?
Negative infinity to negative square root 3. And 0 to square root 3. Square root 3.
No, which means that's wrong.
Sorry. Yeah.
Where are there sign changes? How many?
There's 3.
Which means we have 3 points of inflection. And they occur at square roots too. This is going to be hideous. I hate this problem.
I think we're missing.
We shouldn't be missing anything.
Isn't concave from 0 square root 3 to square root 3 infinity?
It's not. What does it mean to be concave down? F double prime is what? Negative, negative. Positive, positive. Right. Function also cannot be both up and down at the same time. First inflection point at at negative root 3. At least the square's in the denominator. So that's 3 plus 1, which is 4. This is negative root 3 over 4. Thankfully, this isn't a terrible function. Oh, good. Trig is really fun to work with. Then it occurs what, at 0? Oh, good. That's an easy one.
It's just 0, yeah.
Then at square root of 3, right? Which would be positive root 3 over 4, right? Thank all things holy in mathematics that is over. God, that was like a 15-minute problem. And that was tame. This one's not terrible, actually. It's probably going to be one of those days that goes longer than 1 hour. But we'll see. We'll see how tired I get. Monotonicity first. H prime is what?
E to the x minus 2x.
Oh, you beaver. Is that undefined anywhere?
Yes, at negative numbers.
Is it?
No, it's all the numbers, I think, right?
So that's defined everywhere.
So do you pick the natural log?
Let's see.
Um,
Oh, I can't trust this. This is saying one of the zeros is 0. E to the 0 is 1. 1 minus 0 is not 0. Oh, dear. Then you algebra solve. E to the x. Divided by, you said it was minus 2x, right? Versus plus 2x.
Minus 2x plus 0.
need to do n solve. Algebra. Numerical solve. Oh. No solution. I'm gonna go with that then. Okay, so this is definitely wrong. Yay. That's gonna make this problem easier. Empty set. No solution. Yay! Which means we have no critical points, which means it's going to be strictly increasing or decreasing. The question is which one. It's not F, not F. Oh, guess what? Use 0. Positive. That just doesn't sound right. Graph. Oh, no, it is right, okay. Never doubt my math. Where is it increasing?
Everywhere.
Where is it decreasing?
Nowhere.
Empty set, nowhere. Is there a sign change?
Nope.
What does that mean about relative max and min?
No solution. The relative min would be at the vertex.
There's no vertex, it's strictly increasing. Okay, so that wasn't as terrible as I was expecting. But we're not done. What is H double prime?
ES minus 2.
Is there anywhere that is undefined?
No.
What is X?
Ln of 2? I don't know what that is though.
How did you sign? That's 8. What is the value of natural log of 2? No idea, but it's greater than 0. So I can use 0. E to the 0 minus 2. Is that positive or negative?
Negative.
Natural log of 2. No idea. But I know that natural log of 3 is in there. 2 2's larger than 3, right? So natural log of 2 has to be larger than natural log of 3. Plug in log 3. E to the log 3 is 3. That's why I chose it. You also could have just done 1,000. E to the 1,000 clearly larger than 2. Where are we convex?
From -30 to, oh, from ln of 2 to infinity.
Where are we concave?
-infinity to ln of 2.
Do we switch sign?
Yeah.
Let's go. Where do we switch sign?
At ln of 2.
What is h of log 2?
Was 2 minus ln of 2 squared.
That pops up. Let me remind you, unless you're specified otherwise, leave your values exact. That means don't tell me what that is as a decimal. I will take off points. What is P prime?
One minus x minus 1.
It's just 1 over x minus 1, right?
Or 1 minus x over x. Where is that undefined?
0.
What's x if it equals 0?
-1.
Not negative 1.
Positive 1.
What's the domain?
All our numbers minus x.
That'd be all real numbers.
It's 0 to all real numbers, right? I forgot how it works.
0 to what? There's no such thing as 0 all real numbers.
Oh, 0 to infinity, yeah.
Open or closed?
Closed? I forgot.
So you're saying this?
Is that wrong? I don't remember.
Not open.
It's open. Okay.
Do we have interior points?
Yes.
Which ones?
At 1.
Here's what I'm going to do. I can ignore that 0 because it's not an interior point. What's the first interval?
Is it open zeros, comma, 1?
Good.
Amounts 1 to the 30th.
Why is it 0 to 1 and not negative infinity to 1?
Because the domain is 0 to infinity.
Remember, you're splitting the domain. Oh. That sucks.
Taking 0 to
You have to pick a number between 0 and 1. That may use your fractions. Bummer!
half.
Half the work. Now,
It's positive, right?
I'm going to plug it into here. 1 over half is 2. Minus 1 is positive. 1 million. Maybe I should use 100 million.
It's negative.
Yeah, that's definitely negative. Where are we increasing?
0, 1.
Where are we decreasing?
1 to infinity.
Do we have extrema?
Yes.
Which one? And how many?
Maximum? Oh, the maximum is 1.
So no relative min?
Yeah, no,
Where's the relative max?
half 1. Ln of 1 minus 1.
What's log of 1? Say it loud and proud. No? You don't want to say it loud and proud?
Is it 0?
0. Pedo prime.
Floating.
Nope.
No.
Uh,
No.
is it out? Yeah.
So I just have that.
Look at the
Remember.
first one that we wrote.
Yeah.
That doesn't
Oh,
require
right.
closure
There's a
rules.
constant. Yeah. You're right. That makes it easy.
Negative 1 over x squared. Where is that undefined?
As 0.
If pedo prime of x equals 0, what are we saying? Are we saying that negative 1 is 0? Does negative 1 equal 0?
I don't think so.
That is what we call a contradiction. Which means my assumption was wrong. Pedo prime does not equal 0. Is 0 interior?
No.
Means that f prime has no critical points. Oh. Pick one. What's p double prime of 1? Where are we convex?
And, nowhere.
Where are we concave?
0 to infinity.
Is there a sign change?
No.
So no inflection points. Because why not? Why not have piecewise? But look,
So isn't values always going to be 0 and 6? Or am I just...
no, we're gonna have some fun. Oh boy. First things first. Is f continuous at 0?
Yes.
Yes. Which means it might be differentiable at 0. Remember, continuity does not imply differentiability, but differentiability does imply continuity. So if it wasn't continuous, it wouldn't be differentiable. Was that an F? It was. So we have at least this much. The question is,
I'm in, sir.
is it differentiable at 0? So take the one-sided derivatives. Greater than 0. What do you get at 0?
Negative 2. 0.
Less than 0. Oh wait, did I mix that up? Yes, I did. Shame on me. Doesn't matter. Because it's still 0 and 0, right? That means it is differentiable at 0. Is that undefined anywhere? So set n equal to 0 and solve. So I'm probably just going to do this. That means what? 2x has to be 0. So what's x?
0.
What our first interval?
-2, 0.
Technically closed, right? Then what?
0, 2, close bracket.
Here, I can actually choose the endpoints if I so desire. But I'm not going to. -1. So f prime is -1.
Positive.
F prime of 1.
Positive.
Where are we increasing?
Both in.
So what is it?
-2 to 2, close bracket.
Where are we decreasing?
Nowhere.
Do we have sign changes?
Nope.
Do we have endpoints?
Yes.
So do we have extrema?
Yes.
Yes. This is a continuous function on a closed interval. We have extrema. They're actually going to be absolute, but I'm still going to write as relative. What is f of -2?
Is it -2?
Yes. What is f of 2?
6.
Which one's larger?
6.
So that would be the max, right? At 2? We at least have that much. Question is it differentiable, again, at 0? Nope.
No.
Will it ever equal 0?
Nope.
What are our intervals?
-2, 0. And 0, 0, 2.
From -2 to 0, what is the sign?
Negative.
What is it from 0 to 2? Where are we convex?
0 to 2.
And where are we concave?
-2 to 0.
Do we switch signs?
Yes.
So we have an inflection point
Which is 0.
at 0.
Which is 2.
Questions?
No, I kind of like those. They're kind of fun.
Next time we're going to actually apply this. think that's everything, yep. Oh, yeah, your project's due next class.
Did you, or the last?